Howdy folks, welcome to another episode of not Bikes, Burgers, Beers, but amp repairs are back. Well, at least a one-off anyway. What do I have under here? Uh-oh. Marshall JTM30. Not the same one that I repaired in the last videos a couple of years ago. This is a different one, but it's experiencing the same problem. So let's get the chassis out and start doing a visual inspection. Alrighty, opened it up and doing a visual inspection. What I can see from the start is these capacitors, these are the filter caps. They're not standard, so they've been replaced. And you know, some of these, I don't know if it comes up on the camera, but that's looking a bit brown to me. But these aren't the right quality ones. Well, I don't know if they're the right value, I haven't looked yet. They look like they are, 450 volt. 22 microfarad, that's correct. However, they're not the standard ones. These Marshalls, as much as they have a bad reputation, they usually come with Nishikons, which are super high quality capacitors. That's the first thing that stands out. The other thing I noticed is these two capacitors sitting down here. Now, it's a bit dark down here, so forgive me, but that's not standard, so I don't know what's happened there. So those are the two main things I can see straight off the bat. The other thing I can see, some of these resistors, let me see if I can point, this one tucked in between these two big filter caps, they're slightly off-colored. There's a lot of overheating happening in this, which is not uncommon for these amps. And I know, look, it looks like they have been worked on because they are standing off the amp quite a long way off the PCB. Probably a little bit too far if you ask me. These can fatigue and break, and maybe that's what's happened. That one there you can see is just completely wonky. Looks like it might have even been worked on without even taking this PCB out, which is just lazy. I understand the reason why, but don't be lazy. What else can I see? I looked at the transformers, because normally with these overheating, the transformers are also browned. And you can see in my previous videos on the other JTM30s I've worked on. But this one looks pretty good, it looks intact. So I'm gonna leave that alone. And the output transformer over here looks absolutely fine as well. Look, it might just need a recap and a new set of tubes. I mean, even this capacitor here, look at those solder joints. That is not factory. So all of these have been swapped over at one stage, and some of them concern me. So let's keep going with the inspection and see how far we get. One other thing I'm going to say as well is this little indent right here with this plastic grommet. This is where your reverb tank comes and goes, so send and receive. And I have to say, the cable wasn't here, the cable was here, rubbing up against the steel. So I'm going to check to make sure that the reverb cable, which is basically just a shielded RCA cable. They normally go through here and they're protected by this, but it was rubbing up against this. So I'm going to inspect that and make sure that the poor installation of that has not ruined the cable. If so, I'll just have to order a new cable. Alrighty, so I've connected the amplifier to my Variac and an oscilloscope and a dummy load. And I'm slowly turning the voltage up on the Variac. I'm up to about 200 volts AC, and the power light's on, which is good. Except I'm not seeing any heater glow from any of the tubes. So I'm going to shut this thing down and connect some probes up to the 6.3 volt circuit and see what's happened here. It may well just be, could be anything. Could be a broken wire, could be a faulty power transformer with the 6.3 volt circuit, could be a blown fuse. So let's check all of the above. Alright guys and girls, I've got some alligator clips hooked up to my multimeter, got it set to the 20 volt meter range because I'm looking for roughly about 6 volts, but I'm only going to bring the Variac up halfway, so about 120 volts instead of 240. And what we should see here is roughly about 3 to 4 volts AC. So let's see what happens. Variac is on, you can see a voltage little jump there, and as I'm turning my dial, we're getting some AC voltage. That's at 100 volts AC, So we're roughly about halfway-ish, and you can see there's 3 volts. We're expecting 6.3 volts. Now I'm not going to go all the way up because I don't need to. So the next thing I'm going to do, we've got power coming out of the transformer, so that's good news. And we follow these red and black wires. These are the heater wires that go down here, and there's actually 2 points right here. Let me see if I can zoom in. So those ones right in there. We're going to try to check those. However, those 2 points run up, and you can see they run up here to this terminal block, and then they come out of here, and what do we have here? A fuse. So fingers crossed, I'm going to say that maybe that fuse is blown, but let's diagnose and figure out where the power stops, and that's how we can best determine if it is the fuse or not. So let's see what happens. Alright folks, so I actually figured out the problem. It was a dry solder joint. So touch that up, and all of a sudden it worked fine. So we're going to carry on. We did get some heated glow, didn't get it on camera, no biggie. I'm going to order a new set of filter caps anyway, so that's going to get changed. The other thing I'm going to look at once we do that is check the bias, make sure these tubes are actually the power tubes, because the preamp tubes don't actually need to be biased. They're cathode biased, and generally they're fine. You just replace them, off you go. In this amp, this is also pretty much set and forget. You just put tubes in, off you go. There's no bias adjustment. As you see in my previous videos on the JTM30, the bias is adjusted using the Zener diodes, which are tucked in deep in here, these 3. And we'll have a look and make sure they're running okay. But first port of call is replace these filter caps. Righto, so before I go ahead and order parts, we are just going to check the bias of this amp and see how well it's running. I'm going to make sure my volumes are down, because you want 0 signal coming through the amp when you're checking the bias. What I'm going to do is I've connected my multimeter, set it to resistance, and I've got the brown, which is center tap. I've got my red cable going to my positive lead, and the yellow cable going to my negative lead, and that's sitting on red. If we follow the red cable, you can see it goes in here, and basically it solders onto, I believe it is pin 3, which is the plates of a 6L6, and then the white cable, let's follow that, which I'm going to measure next. That's the other side of the center tap of the power of the output transformer. I'm going to measure that next, but that goes to pin 3, I believe it's pin 3, of the other 6L6. So we have to measure both sides. Now, right now I'm measuring the red side, and I'm getting a reading of 82.2 ohms. So we are going to type that in to my bias calculator spreadsheet, 82.3 it's gone up to. This will pretty much stay around that. I'm going to call it 82.2. Let's call it 82.29 because it's flipping around between the two. So let's do that now. So I'm going to go here to my red column and white column. I change these depending on the color of the wires in the amp so I don't confuse things. But we are going to put in 82.29 ohms on this side. Now we're going to go over to the white column and we're going to measure this side. Now technically all I have to do is take this probe and put it on the white cable, so I'm going to put it down here, and the amp is safe. I've discharged all the capacitors and make sure that I've measured them so there's no harmful voltages in here. It's roughly sitting at about 3 or 4 volts right now, so worst case scenario I'll get a nice little tingle if I accidentally touch something, but it should be pretty safe. Alrighty, so I've got the yellow alligator clip connected to the white wire, which goes to the other 6L6, and we measure the resistance on that, and it's sitting on 80.2, 80.1. I'm going to call that 80.19 because it's flickering between the two. So let's put that into our spreadsheet. Now we're going to measure the voltage drop next, and then that will determine what the power dissipation of each tube is. Alrighty, so I've got the amp switched on, full power going straight into the mains, and On the white wire, we're getting about 3.77 volts. It's averaging out to about that. So let's turn the amp off. 3.77 on the white wire. That's what we're going to put in as a voltage drop, 3.77. I'm going to move this yellow cable back to the red cable and we're going to measure the voltage drop on that side. Alrighty, I've connected the yellow cable to the red cable on the power transformer. Let's flick the amp back on. Give it a second for the heaters to light up, and we'll flick the amp on and we'll measure the voltage drop across the other side of the power transformer. And then finally, we will measure the plate voltage going to the pins of our power tubes, our 6L6s. So on this side, it looks like we're getting about 4.44, and it's pretty stable. Big difference in voltage drop there. So let's turn the amp off and type in 4.44. Now you can see with current calculations, because I haven't put in the plate voltage yet, it's saying it's running at 23 watts on one side and 20 on the other. Obviously that's incorrect. So the last piece of the equation is the plate voltage drop on both sides. Let's measure that. All right, to measure the plate voltage, I've set the multimeter to the highest level I can go up to, or highest value, which is 1000. Generally, most tube amps that we work on, guitar tube amps, will not surpass 1000 volts DC, so it's pretty okay there. And most general multimeters won't surpass 1000 volts measurements anyway, and most of these probes are not really rated for higher than that either. So I've got one side connected to ground here, which is perfect. Now the other side, once I get the amp on, I'll warm it up, and I have to find pin 3 of these power tubes, which I know which ones they are, so I'll have a look at that, and then that will determine, or that'll help me find and measure the plate voltage, which will finalize my calculations, and it'll tell me how hot or how cold this thing is biased. Alrighty folks, amp is on, warming up. It's in full play mode because in standby you won't get plate voltage. So I'm gonna reach in here very carefully. I apologize if I lose you, but I'm gonna be extremely careful because you don't want 400 plus volts going through you. And there it is, 432 volts. And I would imagine the other side would be pretty much the same. Let's check. 432 volts. So let's turn the amp off, let's turn the multimeter off, and let's type in 432 volts. 432 volts. You can see this side's running at 23.3 watts, so it's over 100%. And we can see this side here is running at 20.3 watts, which is just under about what, 80% or 85%, 90%. So if I fill in the rest of these details here, I will get a percentage and it'll hopefully confirm what I'm thinking. We can see that the red side's running at 101.3 and the white side is running at 88.3 there on the bottom of the page. Plate current 53.9, let's call it 54 milliamps, and this side's 47 milliamps. That is both just way out of spec. It's running hot as all hell. So we're gonna have to bring that voltage, that plate dissipation down. Ha! Jamico, for starters, rubbish brand. Secondly, way overvalue, 100 microfarad. That's ridiculous. It should be 47 microfarad. Here's an example. 450 volt, 47 microfarad, Nishikon. Good brand, buy that. Also, notice no bulging on the top. That is what we're replacing these caps with. Now here's one of the ones that has the bulging top. You can kind of see that's a bit more obvious now that it's out of the amplifier. And yeah, we're just going to go ahead and replace these faulty caps and shove the new ones in. Alrighty, so new tubes are installed. I've put in 3 brand new 12AX7s and 2 brand new 5881s. I noticed these 5881s, even though they have the wafer base, these are the old ones here, Sovtex, made in Russia. No political comments, or I'll delete your posts. But we're not red plating, and the bias is just sitting under where I'd be comfortable, but I know these amps run really hot anyway, so I'm not going to do any more. It looks like the filter caps have done a great job in sorting that out. I'm going to show you what the sine wave looks like now. So here's the sine wave, nice and clean, and you can start to see it deforming slightly. And there's the distortion, and you can hear that through the load resistor there. I'm going to switch this off. I'm going to plug it, I'm going to install it back into the cabinet, and I'm really happy this is done. This has been on my bench for quite some time. In fact, I think over 6 months. And the reason being, it was just COVID and getting parts and all that sort of stuff has been a nightmare. And in addition to that, it was also a nightmare just trying to get the time to do this, because then once COVID was over, I had touring. Once touring was over, unbelievably, the rains came, and it's been raining for months and months, but it just got heavier and heavier and heavier. And unfortunately, the other day, my house finally let go. I had some flooding, and I've had a little bit of damage, unfortunately. Luckily, my customer amps were okay. Look, guys, I just want to say thanks again for watching. Look, there's not going to be any amp repairs on the channel anymore, and it might happen once or twice here and there, but I'm getting out of it. I'm going to be selling a lot of my test equipment, and I'm just going to keep the basics to do my own repairs and bits and pieces. I want to thank everyone who has subscribed to the channel because of the amp repairs and bits and pieces. Thank you so much. There will be other amp repair videos. There'll be a lot of other electronic-based repairs and bits and pieces, but predominantly the channel is morphing into something else now, which is basically Bikes, Burgers, Beers, hence the channel name change a couple of years ago. And I just want to say thank you all who have supported me. I just hit 1,000 subscribers about a month and a half ago. That's been amazing. Thank you so much. And I hope this video helped you. And if it didn't, that's okay. Hit the thumbs down. If it did, hit the thumbs up, subscribe, and there's loads more stuff coming along the way. I'm going to finish this up. Oh, I need to replace these last 2 caps as well. I didn't do them because A, there's nothing wrong with them. B, I wanted to mainly do the main filter caps here just to make sure that this amp biases correctly. And it looks like it is. So, hey, win-win. Alright folks, well, here's the amp. That's the dirty channel. The amp's been on for about an hour now, and I have to say, this top section here that's normally, well, it gets so hot that if you touch this screw, you'll burn your finger. I can keep my finger on there now, and the amp is on, and you can see standby is off as well, so the amp is switched on, and it's making noise. Been on for a couple of hours now, soaking, and no red plating, no heat. Another JTM30 cooled down and tamed purely just by changing some of the capacitors and making sure the bias is actually correct. Thanks, Marshall. You've done it again. Clean channel. That's on the bridge pickup, so let's anyway, you get the idea. It's all working fine. Volume's on 2, master volume's on 2, preamp volume's on about 5, so halfway, but it does crank. I don't want to distort the microphone. I've got the EQ sort of set at about bass on 2,
Mid-range is about 4, 5, and treble is on about 2 or 3. And it's all working good except for the reverb, so yeah. Anyway, I'm a bass player. You get the idea. Amp's working great now. Sine Wave's lovely, which you just saw. So, hey, thanks everyone for watching. Hope you enjoyed today's video.